Hey, Algebra 2, in this video, like it says, we're going to solve an exponential equation using logs. So, we're going to do a few different kinds of examples. The first example I would like to do is, again, we're just going to be solving for x. We're going to do 27 equals 9 to the power of x plus 5. So, we don't want our x in the exponent, right? We want it down here. We want x equals. That's our goal. You might be thinking we could do log base 9 of 27 equals x plus 5, but that means we would have to use the change of base formula. Something we can do here, speaking of change of base, is actually look at the bases and go, hey, wait a sec, I could rewrite this with a base 3 and I could rewrite this with a base of 9. So that's exactly what I'm going to do. 27 is the same as 3 cubed, and 9 is the same as 3 squared. So I haven't changed the problem at all. And now what we can do is use the property of equality, but it's for exponents. So I can rewrite this as 3 equals, the exponents are equivalent, 2 times x plus 5. So like I said, that is the property of equality. Property of equality. Which says if you have b to the power of x equaling b to the power of y, then x equals y. So now this is way easier to solve for. It's just basically an algebra 1 problem. I'm going to distribute my 2 to get 2x plus 10. I'm going to subtract 10 to start to isolate my x. And 3 minus 10 is negative 7. And then I'm going to divide by 2, and I get negative 7 halves equals x. And that's it. And we can leave that as an improper fraction. So another example, slightly harder, is what if we can't change the base? So let's do solve for x. And maybe we have 8 to the power of y minus 4 equals 7. So one thing we can do, right, there's nothing I can do to change my base so that these are both base 8 or 7, right, or 2, right? This is as low as it gets. So in this case, what we can do is take the log of both sides. So I'm going to take the log of 8 to the power of y minus 4 and take the log of 7. Now we still have the issue that our variable that we want to solve for, I guess I said solve for y, I just realized. Whoops. I mean solve for x. So should be solve for y. Anyways, so I don't want this up here, so what I'm going to do is use the power property for logs and bring that y minus 4 down here. And I have log of 8 equals log 7. And then I want to get this by itself, and right now it's all being multiplied by log of 8, but if I just move this to the other side, then it'll be alone. So because we're multiplying, I'm going to divide. So then we get y at minus 4 equals log of 7 divided by log of 8. And then all that's left to do is to add 4 to both sides. So I'm left with log of 7 divided by log of 8 plus 4. Now this is our exact answer, but you're likely going to be asked for an approximate answer as well. And this is why we took log base 10 of both sides, so then we can just use a scientific calculator. I don't have a scientific calculator with me, I just have my graphing, but we can still do it. So I'm going to put this whole thing in parentheses. So in parentheses, I'm going to do my numerator log of 7 divided by my denominator log of 8. And then I'm going to close my parentheses for the whole fraction and add 4. And let's round to the nearest thousandth. So that means that y is approximately 4.936. And then we're done. So we have our exact and our approximate answer. Now let's do another one, just one more problem, solving for x This time I'll just have it be x. All right, so let's do 12 to the power of negative 8x equals 13 to the power of negative x plus 8. So again, first thing you should always see if you can do is do change of base, but that's not going to work here. So I'm going to take the log of both sides. Now what makes this problem a little bit harder is we have two exponents, but not just that, we have two exponents that both have logs or x's in them, excuse me. So we're starting off strong, we're taking the log of both sides. We're going to use the power property again. So this is negative 8x times log of 12. And then I'm going to put this in parentheses, negative x plus 8, because it's all being multiplied by log of 13. Now here's the issue, right? We've got an x on both sides. We want them together. You might want to try adding x, but we can't because it's locked in this parentheses. And you might want to divide, right, by log of 13, but then we're still stuck with this, right? It's kind of locking this into place. So what we want to do now is distribute this log to both numbers in the parentheses. So bring down my negative 8x on the left side. And then I'll have negative x times log of 13 plus 8 log of 13. And that's really nice, right? Because now my x is more alone. At least it's separated from these parentheses. But we still want to try to get our x's on one side. So I'm going to add this x to the left side so that they're closer together, even though we can't necessarily combine them. So that will make this negative 8x times log of 12 plus x log of 13 equals 8 log of 13. All right, so I can't combine them, but this term and this term both have x in common. So what we can do is factor that greatest common factor of x, right? So that negative 8x divided by x is negative 8, and it's still being multiplied to 12. X divided by x is 1, so I'm just going to have 1 times log of 13, or log of 13. And then bring down my right side. And now we've done it, right? We've got x completely by itself. Well, not yet, but almost, right? But we just have one x, and that's really nice. So now all we have to do to get x by itself is divide both sides by this, since this is being multiplied together. And we are left with x equals 8 times log of 13 divided by negative 8 times log of 12 plus log of 13. Now we're going to want to get an approximate answer as well, so I'm going to do this in my calculator. When you're doing this in your calculator, what you're going to want to type, so here's just a little tip. Okay, so you're going to want to do parentheses 8 log, and then your calculator is automatically going to put your log in parentheses. So do your whole numerator, press the divide button, and then you're going to type parentheses negative 8 log parentheses 12 plus log parentheses 13, and then close your parentheses for the whole denominator. So this is what it looks like. So like I said, parentheses 8 log, there's the parentheses for my 13. Close my parentheses for the numerator, divided by parentheses for the entire denominator, negative 8 log of 12 plus log of 13. And then don't forget to close your parentheses for the entire denominator. And let's round to the nearest 10,000, so 10th, 100,000th. So it'll be approximately negative 1.185. And then we are done. So here are a few examples. You want to try to use change of base, right? Get a common base if you can. It'll make the problem easier. But But if you can't, you can always just take the log of both sides.